Welcome back. Let's continue with question 14 on the mixed exercise of chapter 1. So over here, we've been given this expression and we need to essentially expand it and then equate the coefficients. So let's get started in expanding this section. So we have an x and we're going to multiply it by the equation. So I'm going to get x cubed plus bx squared plus cx, and then I'm going to switch to a color where I'm then going to multiply uh, the quadratic by 3. So we're going to get plus 3x squared plus 3x plus 3c. Now what I'm going to do is essentially equate these values to what we've been given. So let's have a look at this. And we already know our answer that we should get is x cubed minus x squared minus 17x and minus 15. Now, can you see how all of these align? So imagine if I were to put a dotted line across all of these, we can start to form some equations. So firstly, I can say that let's just skip to another color. I can say that the equations, the coefficients are going to be the same in the x cubed term. So we can leave that. Now for the next equation, we can say that bx squared plus 3x squared equal to minus x squared. So from that, we've just taken the x squared coefficients. Now we can cancel them and we can essentially say that b plus 3 is equal to minus 1. We also know by looking at the very last equation, if we take this for example, we know that 3c should equal to minus 15. So from this, we can take that c is equal to minus 5 and b should equal to minus 4. Okay, just to go over this technique again, what we've done is we've compared the coefficients of our answer and the respective terms. So we've compared the x cubed coefficients, we've compared the x squared coefficients and also just the constants as well. As we know that 3c is going to have to equal to minus 15. Now, here we have our answer. We've got b equal to minus 4 and c equal to minus 5. If you were to sub that into the equation, you would end up with the answer as well. Okay, let's move on to part B. It says we need to fully factorize it. Now, they've already done half of the factorization for us, and we know that we've got x plus 3, x squared minus 4x minus 5. Now we just need to factorize the second part. So I'm simply going to come up with two numbers that multiply to make minus 5 and add to make minus 4. So it is minus 5 and plus 1. They add to make minus 4 and they multiply to make minus 5. So we have x plus 3, x minus 5, and x plus 1 as our answer. Let's move on to the next question. In this question, we've got, given that y is equal to 1 over 64x cubed, express each of the following in terms of kx to the power n. Okay, so again, for this type of question, we need to just substitute it. So I'm going to start off with, let's just go into here. I'm going to start off with 1 over 64 x cubed to the power 1 over 3. Now we're going to do this in separate stages. Firstly, I'm going to do 1 over 64 to the power 1 over 3, and then I'm going to do x cubed to the power 1 over 3. Now, 1 over 64 to the power 1 over 3 is the same as taking the cube root of this. And this over here, we can multiply out the powers, shouldn't be equal to, it's just going to be x on its own. So overall, the answer is going to be x over 4 as our answer, and that is in kx to the n terms. Now we will simply do it for part B. So we've got 4y to the minus 1 Now what we've got to do is do 4 multiplied by 1 over 64 x cubed to the power 1 to the minus 1. Now in this example, everything that is to the power minus 1, it will flip. So what we've got to do is we've got to write this as 4 times 64 times x cubed. Okay, so all I've done is I've flipped both of the numbers. So 64 has gone to the top and x cubed has gone to the bottom of the fraction because it's now going to be x to the minus 3. So if I multiply this out, I'm going to get 256 x to the minus 3 because we need to make sure that it's written in this form. And there's our answer. Nice and easy, 1 mark each. Let's have a go at this next question. So we've got to show that this surd can be written in the square root a plus square root b form. Okay, so let's get started with this. Now, the first thing that I'm going to do is rationalize the denominator. And before I do that, I'm going to stick to my method of finding the square numbers. So I can essentially pull something out of the square root. So the numbers that we're looking for when it comes to making it simpler are always going to be square root 4, square root 9, square root 16, and square root 25, square root 36. These square numbers are going to be useful because we know that they go into 2, 3, 4, 5, 6, and so on. This makes it a lot easier for us to work with them. So if I rewrite this as square root 25 times square root 3 minus square root 25 square root 2, it's going to become a lot simpler to work with because I can simply change this to 5 over 5 root 3 minus 5 root 2. And as you can see, there is a 5 everywhere. So hence, we can cancel and simplify down the 5s. We can divide through by 5s, and we're just left with 1 over root 3 minus root 2. Now, all I need to do is multiply this by the conjugate. So the conjugate of this would be root 3 plus root 2, root 3 plus 2, root 2. Remember, we multiply the top and the bottom, so the denominator both by root 3 by plus 2. And we are going to end up with root 3 plus 2 over 3 minus 2. Just once again, please remember that this makes use of the difference of squares. So whenever we have a minus b and a plus b, we end up by getting a squared minus b squared. Now, because it's root 3 whole squared minus root 2 whole squared, we can write this as just 3 squared, just 3 minus 2. So that ends up being 1, and our final answer is root 3 plus root 2, and that's exactly the form that we're looking for. We're looking for root a plus root b. So here is our answer. Perfect, and that's a very nice easy 5 marks. Okay, let's have a look at question 17. Here we've got to expand and simplify. So I'm going to do the FOIL method. So just to recap my FOIL, this is my F, this is my O, this is my I, and this is my L. Okay, so we're going to do the first terms, we're going to multiply them together. So we're going to get 5 root 11. Then I'm going to do my O's. So I'm going to get minus 11. Then I'm going to do I, so I'm going to get minus 25. And then finally, we're going to do L, so it's going to be plus 5 root 11. Overall, I end up getting 10 root 11 minus 36. That's expanded and simplified. Let's move on to question number 18. On 18, we've got x minus 64x cubed. Now, straight away, I can pull out a factor of x because they're both divisible by it. So it's simply going to be 1 minus 64x squared. And now I can see that this is also a difference of squares. Because remember, a squared minus b squared is also equal to a plus b, a minus b. It's the same thing. It's just the other way around in this question. Now, I can rewrite 1 minus 64x squared as 1 plus 8x and 1 minus 8x. Okay, so putting that all together, we get x, 1 plus 8x, and then 1 minus 8x. Let's move on to question number 19. We've got to express 27 to the power 2x plus 1 in the form 3y. Now, please be aware of this question. Questions like this have been known to come up, so it is something that you should be aware of. At a first glance, it looks very difficult, but let's get straight into it. So we essentially are going to start off by expressing 27 in base 3 form, because that's how we've got to express it. So I know that this is the same as 3 to the power 3 multiplied by 2x plus 1. Now, if I expand this out, I'm going to get 3 to the 6x plus, whoops, I made a rookie error there. It's going to be 3 to the 6x plus 3. Okay, just make sure that you expand the 3 out as well. There we go. If I've made the mistake, hopefully you won't. And we know that this is y, and we've got to essentially write y in terms of x. And I can say that because my y, let's essentially write it as 3y. So I know that my y is equal to 6x plus 3. And there is my answer. Okay. Thank you very much for listening.